One summer day, on August 23, 1856, a gathering of scientists occurred in the city of Albany, New York. It was the 8th Annual American Association for the Advancement of Science meeting. This significant day celebrated the many discoveries and achievements of noteworthy scientists. Several papers were read, including one that showed how carbon dioxide could cause the Earth's temperature to rise. It was titled Circumstances Affecting the Heat of the Sun's Rays. It was written by Eunice Newton Foote, the world's first female climate scientist. She was also the first female scientist in the United States to be published in a peer-reviewed journal 54 years before Marie Curie's work was published. On that momentous day in 1853, the paper was not read by the author, but rather by a male scientist, Joseph Henry, from the Smithsonian Institution. Foote was never acknowledged as a legitimate climate scientist. That is, until 2011, when historian Ray Sorensen realized Foote was the first climate scientist to conduct this groundbreaking study, leading us to understand climate change and the steps we must take to save Mother Earth. Welcome to Math, Science, History. The history of math is our intellectual foundation for understanding science. Science, beautiful, remarkable, awe-inspiring science. It's the creative foundation for our ineffable future. Hi, I'm Gabrielle Burchak, and this is my podcast, Math, Science, History. In the year 415, the infamous philosopher and mathematician Hypatia of Alexandria, Egypt, was savagely murdered by church monks. This murder shocked the Roman community and its government leaders. Hypatia was known far and wide as a respected philosopher, mathematician, government advisor, and a professor. Hypatia, The Sum of Her Life, is a book that I wrote that looks not just at the circumstances surrounding her death, but also at the sum of her entire life. I weave in the details of her education, disciples, Neoplatonic philosophies, female contemporaries, and the many mathematics that she wrote and taught about. There is truly more to Hypatia's life than her death. Hypatia, The Sum of Her Life, written by me, Gabrielle Burchak, is now on sale on Amazon. Buy your copy today. The story of Eunice Newton Foote is an inspiring one. She grew up in the 19th century and became a scientist, an inventor, and a suffragette. She was born Eunice Newton in 1819 in Connecticut and was a distant relative of Isaac Newton. Her family moved to Ontario County in western New York in 1820, where he ran a farm. As a side note, when her father died in 1835, her older sister Amanda stepped up to save the farm and pay off the property debts. Amanda became the sole owner of the family farm and kept it from being sold. That, in and of itself, is an inspiring story of female resilience. It's kind of like my grandmother, who, after my grandfather passed away, saved her farm while raising 9 children. I love stories of resilient women. Speaking of, back to Foote. Growing up, she attended the Troy Female Seminary, a burgeoning women's preparatory school. The school was exceptional because it wasn't like most finishing institutes at that time. Students were encouraged to study the arts, history, literature, mathematics, philosophy, and science. In addition to attending the seminary, Eunice and the other students were encouraged to attend the science courses at the nearby Rensselaer School, led by Amos Eaton, a professor who advocated for women's education. His pedagogy was steeped in the importance of lectures and practical experimentation instead of simple memorization. At Rensselaer, she also studied astronomy, chemistry, geography, meteorology, and natural philosophy. Her education empowered her with the ability to conduct research and laboratory testing. And like me, she was a little lady at 5 feet 2 inches tall. Power to the little ladies, right? It's like my mom used to say, dynamite comes in small packages. In 1841, she married Elisha Foote Jr. and had 2 daughters, Mary and Augusta. Elisha was a lawyer who trained under New York Judge Daniel Cady. Elisha did quite well, so much so that he was able to purchase property in New York and eventually sell one of the houses to Daniel Cady. Cady then handed the deed over to his older daughter, Elizabeth. This is the same Elizabeth Cady who married a gentleman named Henry Brewster Stanton and became known as Elizabeth Cady Stanton, one of the founders of the suffragette movement. Hence, Stanton and Foote's strong relationship inspired and encouraged each other and other women to speak up for women's rights. Foote, encouraged by Stanton, was one of the earliest attendees at the 1848 Seneca Falls Convention, also known as the First Women's Rights Convention. Foote and her husband were signatories of the convention's Declaration of Sentiments, which demanded equal rights for women and the right to vote. Foote was an exceptional individual who upheld a steadfast career as a suffragette and scientist. A year after her work with carbon dioxide, she conducted experiments on static electricity. She authored a paper titled On a New Source of Electrical Excitation. She was inspired by the hypothesis that the Earth's magnetic field and polarity might be determined by studying the electric charges in our atmospheric pressure. The purpose was to study the vapor content of gases that could generate static electricity. It was not a simple experiment. Foote had a glass tube about 2 feet long and 3 inches in diameter, sealed at each end with brass caps. She then used an air pump to adjust the air pressure in the glass tube. One cap held a gold leaf electrometer and the other was attached to the pump. The gold leaf electrometer allowed her to measure the electrical charges within the tube. She would then vacuum out the air in the tube and replace it with oxygen, hydrogen, carbon dioxide, and dry and damp air. She could then analyze the moisture content by expanding or compressing the air. Her goal was to find out how much static electricity could be produced. This article was published in the 11th issue of the Proceedings of the American Association for the Advancement of Science. It was longer than her first paper, and it was also published in the American Journal of Science and Arts and in the Philosophical Magazine. Foote was also an inventor. In 1842, her husband Elisha filed a patent on a thermostatically controlled cooking stove. However, it was Eunice that created this invention. She would often publish her inventions in her husband's name because, as a married woman, she could not defend her patents in court. She even admitted to this process to Elizabeth Stanton when Stanton was visiting her office in 1868. Foote told her that she believed that half of the inventions that were filed for patents were made by women. So, let's look at the numbers now. In 1868, 12,544 utility patents, also known as inventions, were filed. That means, according to Foote, approximately 6,000 of those inventions were created and designed by women. And though we know the brilliance of women has been silenced for millennia, this insight by Foote magnifies our silence and unwilling anonymity on an exponential level. Filing the stove patent under her husband's name was a good decision on her part, though. In 1857, her stove patent was infringed upon, and her husband, an attorney, was allowed to defend the patent in court, a case in which he won a sizable settlement. In 1860, Foote began filing patents under her own name. She filed a patent for a single piece of rubber that prevented squeaking boots and shoes, and invented a skate that did not have straps. She also invented a paper-making machine that allowed printing companies to manufacture paper at a lower cost. To circle back to her work as a climate scientist, Foote's work on analyzing carbon dioxide in the glass tube led her to hypothesize that the quote, atmosphere of that gas would give to our Earth a high temperature, unquote. The experiment involved analyzing interactions of sunlight on gases. Using 2 cylinders, each holding 2 mercury in-glass thermometers, she used an air pump to remove the air from one cylinder and then compress the air in the other. When the cylinders reached room temperature, they were put in the sunlight. She then measured the variations of temperature. She also set the cylinders in the shade. She would then dehydrate one cylinder and then add water to the other to measure the tube's temperature with the dry air or moist air. In her study, she found that the amount of moisture affected the final temperature inside the tube. She conducted these experiments on air, carbon dioxide, and hydrogen. Her experiment found that the tube that held carbon dioxide was hotter than the others when they were in the sun. She also found that it took much longer to cool when it was in the shade. Her study was groundbreaking, even though it had been found that Horace Benedict de Saussure in the 1760s used comparable equipment in his experiments. And Joseph Fourier in the 1820s theorized that atmospheric gases trap solar heat. However, as noted in Foote's discovery, these previous scientists did not find that the solar heat was created by carbon dioxide and moisture in the air. Until about 2011, Irish physicist John Tyndall was believed to be the world's first climate scientist when he used spectroscopy to study the infrared spectrum. This infrared spectrum is a type of heat that radiates from the planet towards space. His work was published in 1859, 3 years after Foote's. At the time when Foote's work was printed, it was published in the United States and in Canada. However, it was not published internationally. Furthermore, Canadian and United States research was inaccessible in Britain and Europe in the mid-19th century. So, possibly, Tyndall did not note Foote's study because he didn't even know of her work. Had Tyndall had access to Foote's research, it might have significantly altered his research to further validate how carbon dioxide and water vapor contribute to greenhouse gases, which heat up the planet, also known as the greenhouse effect. The greenhouse effect is created by two elements: abundant carbon dioxide and water vapor in the Earth's atmosphere. Carbon dioxide is mainly produced by human activities, including burning fossil fuels such as coal, natural gas, and oil. It is also caused by deforestation and the burning of certain gases from industrial plants. When the sun's rays reach the surface of the Earth heats up, emitting infrared radiation back to the atmosphere. The carbon dioxide molecules in the atmosphere absorb some of this infrared radiation, preventing it from escaping into space. When the carbon dioxide absorbs this infrared radiation, it re-radiates some of that energy back towards the Earth's surface. As a result, the heat becomes trapped within the planet's atmosphere. Water vapor, as shown by Foote, is another abundant greenhouse gas in the Earth's atmosphere. The difference between water vapor and carbon dioxide is that the concentration of water vapor varies depending on its location and temperature. Water vapor is created when water evaporates from our oceans, lakes, and rivers. Water vapor also acts like carbon dioxide. It is capable of absorbing and emitting infrared radiation. Again, when the sun heats the Earth's surface, the water vapor in the atmosphere absorbs some of the outgoing infrared radiation, which traps it. With water vapor, it becomes cyclical. When the Earth heats, it increases atmospheric water vapor concentrations, which in turn increase the planet's temperature. As a result, the Earth heats up in a perpetual process. It was in 1856 that Eunice Newton Foote realized that these two components could heat up the Earth. Since then, many scientists have validated her findings. So, as we see, scientists have studied the heating up of our planet for over a century. Foote's discovery served as one of the first initial warnings. Thus, her contributions have shaped how we have come to understand climate change. We are now living in an anthropogenic age, which is the age where our activities are dominating the environmental process of the Earth. We are currently facing an existential threat as greenhouse gases are altering our climate. We are watching forests become decimated by fires and observing crops and fisheries fight through a developing crisis. And we are seeing areas become utterly incapable of being inhabited. Hurricanes, floods, and droughts are now widespread worldwide as we face an unpredictable future. Humans and animals are losing their habitats as areas dry up and other regions become overwhelmed by rising waters. The Natural Resources Defense Council notes that 50% of all animal species now face the possibility of extinction, and some of the world's poorest countries are now the most vulnerable to climate change. Furthermore, a 2018 report from the World Bank notes that by year 2050, 140 million people will be displaced from their homes. It is concerning to think that less than 200 years ago, this petite, brilliant woman discovered this in 2 little tubes and recognized that carbon dioxide could heat up the planet. She provided the foundation for our current understanding of climate change. Eunice Newton Foote's advanced work pioneered the study of climate science. Her inventions were numerous and have made our lives easier. Additionally, she wasn't just a scientist. She worked tirelessly for women's rights. She served on the editorial committee for the Suffragette movement and contributed to the convention proceedings at Seneca Falls. Foote was a trailblazer in every sense of the word. She fought for the sisterhood and exemplified the brilliance and resilience of women and mothers. Honoring Foote during the week that we celebrate Mother Earth is justifiable and poignant. Women, including trans women, and our planet deserve to be held up, respected, valued, and treated with integrity. Foote perfectly showed how many women contribute to more than just the places that society wants us to remain. As women and trans women, may we be like Foote, a powerful being who can protect and uphold this planet to make it a better place. Thank you for listening to Math Science History, and until next time, carpe diem.
Thank you for joining me at Math Science History. If you enjoy this podcast, please subscribe to the show. If you could also please leave me a rating or a review, I would love that. If you want to learn more about the history of math and science, please visit me at mathsciencehistory.com. And if you like what you're listening to, please feel free to click on that coffee button and buy me a cup of coffee. Every cup of coffee that you buy helps me keep this podcast up and running. Also, if you're interested in leaving me a comment or chatting with me, you can always find me on Twitter, Facebook, Instagram, and Goodreads. Just search for Gabrielle Burchak. Thanks for listening. Until next week, carpe diem.